Hi everyone, in this video we'll be looking at the Bernoulli differential equation. Now the Bernoulli differential equation is an equation of the form dy dx plus p of x y equals to q of x y to the power of n, where n is a real number. Now we observe that if n equals to 0, this equation becomes dy dx plus p of xy equals q of x. That is when n equals 0. For n equals to 0, we have this, and this is the standard form of a first order linear equation. We treated this in the previous video. You can check the link to this video in the comment section. Now if n equals 1, we also have dy dx plus p of x y equals q of x y, and this can be written as dy dx equals q of x minus p of x y. Now it's a separable equation. You can check the video on separable equations to know how to solve such equation. So in general, we assume that our n is not equal to 0 nor 1. Now to solve a Bernoulli equation, we need to transform it to a linear equation of this form. Now to do that, the first step, step 1, we divide through by y to the power of n, or multiply through by y to the power of minus n. So if we divide by y to the power of n, we have y to the power of minus n dy dx plus p of x y to the power of 1 minus n equals q of x. Now let's call this guy equation star. Now step 2, we now introduce a new variable v, where v equals to y to the power of 1 minus n. Now if we differentiate v with respect to x, we have dv dx equals 1 minus n y, 1 minus n minus 1, that gives us minus n, dy dx. Now anytime you are differentiating a y variable, you need to add the dy dx. Now if you look carefully, you will observe that this expression here is the same as what we have here, and then this is v. So we can substitute this into this and get so if we make this the subject, we'll have something like y to the power of minus n dy dx equals 1 over 1 minus n dv dx. So we can substitute this for this in equation star. So we get 1 over 1 minus n dv dx plus p of x y to the power of 1 minus n is v equals q of x. So if we multiply through by 1 minus n, we will have dv dx plus 1 minus n p of x v equals 1 minus n q of x. So and we can rewrite this equation if we call this p1 of x and call this q1 of x. This last equation becomes dv dx plus p1 of x v equals q1 of x. So this equation is now in the form of this, a linear equation. So we have a linear equation in variables v and x. So we have successfully transformed our original Bernoulli equation to a first order linear equation in v and x. So we can go ahead in solving this equation by the method used in the previous video on linear equations. Now let's see an example on how to solve a Bernoulli equation. Solve dy dx minus 3 over xy equals to x to the power of 4 y to the power of 1 over 3. So here we observe that our n equals 1 over 3, and our p of x equals minus 3 over x, and then q of x equals x to the power of 4. We now transform this equation to a linear equation. Now to do that, we first divide through by y to the power of 1 over 3, or we multiply through by y to the power of minus 1 over 3. So if we do that, we get y to the power of minus 1 over 3 dy dx minus 3 over x y times y to the power of minus 1 over 3 equals x to the power of 4. And this gives y to the power of minus 1 over 3 dy dx minus 3 over x y to the power of, this is 1 minus 1 over 3. That should give us 2 over 3 equals x to the power of 4. Let's call this equation star. Now we now introduce a new variable v. Let v be equals to y to the power of 1 minus n. That is, v equals to y to the power of our n is 1 over 3. So 1 minus 1 over 3 gives us 2 over 3. So dv dx equals 2 over 3 y, 2 over 3 minus 1 gives us minus 1 over 3 dy dx. Now, if you look carefully, we observe that this part of the equation, this expression, is the same as what we have here. While v, this is our v equals to this guy. So we can substitute this into equation star to get, if we make this guy the subject, we would have y to the power of minus 1 over 3 dv dx equals 3 over 2, dy dx here, dv dx. So if we do that substitution here, we have 3 over 2 dv dx minus 3 over x, y to the power of 2 over 3 is v, equals x to the power of 4. Now we multiply through by 2 over 3 to get dv dx minus, we'll have 2 over x v equals 2 over 3 x to the power of 4. We now have a linear equation in v and x, where our p1 of x equals minus 2 over x, and then our q1 of x equals 2 over 3 x to the power of 4. Now to solve this, we find our integrating factor, which is equals to the exponential of integral of p1 of x, that's minus 2 1 over x dx. And this is equals to exponential of minus 2 ln x. If you integrate 1 over x with respect to x, you get this. And this is equal to exponential of ln x minus 2, which is equal to x to the power of minus 2. So we now multiply this equation by our integrating factor to get x to the power of minus 2 dv dx minus 2 over x, which is the same thing as 2 to the power of x minus 1 times the integrating factor x minus 2 here equals 2 over 3 x to the power of 4 times the integrating factor x to the power of minus 2. So we have x to the power of minus 2 dv dx minus 2 x to the power of minus 3 equals 2 over 3 x to the power of 2. And we observe that this is the product rule of d dx of the integrating factor x to the power of minus 2 times v. we can verify that if we differentiate this, we get this, which is equals to 2 over 3x squared. Now, if we integrate both sides, we have x minus 2v equals integral of 2 over 3x squared. And so if we integrate this, we have 2 over 3s cubed divided by 3. So which is equal to, we have x minus 2v equals to 2 over 9x to the power of 3 plus a constant of integration c. So divide through by x to the power of minus 2, we have v equals 2 over 9 x cubed divided by x to the power of minus 2 plus c over x to the power of minus 2. And this gives 2 over 9 x to the power of 3 divided by this gives 3 minus minus 2, that is 5, plus c x to the power of 2, v. But recall that our v equals, v is y to the power of 2 over 3. So we have y to the power of 2 over 3 equals 2 over 9 x to the power of 5 plus c x squared. And this is the solution to the Bernoulli differential equation. I hope you enjoyed this video. If you have any question, you can drop them in the comment section. Thank you.